Welcome to the last slot for today. Let's start with my talk. I want to show you how to build simple CRUD services with Spring Data REST today. Short infos about me. My name is Andreas Bräu. I'm a software developer from Berlin, working at Idealo. I studied ages ago computer science with a focus on databases. And I also do a lot of DevOps stuff in my job, in my hobby projects. I'm active in Freifunk.net. That's an initiative for free and wireless networks in Germany. We try to establish easy network access for people there with hardware you can buy everywhere, and I also like open source software. I contribute a lot, and I use a lot of more software. But today we want to speak about CRUD services, so we ask 100 people. Unfortunately, we can't play that game for now, as we don't have enough time for that. What do we need to create a CRUD service? Whom of you knows what CRUD stands for? Nearly everyone, but some arms didn't rise for now. So C is for create, R is for read, U for update, and D for delete. It's these are the basic four operations for services we need to put some data in there and to get some data and to manage the data we have in there. So what do we need? Of course, we need to connect to a database or something where we store the data. We need to create database-specific queries for our service to access the data or to write data to the backend. And according with this, we need to build query statements. We need to think about what data do we want to query, what do we want to get back, or what data do we need. Of course, we need controllers with endpoints, so we can access the data via REST. And at the end, we also have to analyze the result sets to work with the data in that way. Some of you might now say, wait, a lot of these things are already done by frameworks or other things. That's correct. Connection to the database is today usually done by framework. We don't need to care about database drivers anymore. We also don't need to write our own queries to access the data in the database. This is almost done by the framework too, and they provide us methods to access the data. It's the same for query statements. We define our domain model within the application, and we don't need to know everything of this and create a statement out of that. But we still need to create controllers for the service to access the data or to update, create, delete data, and we still need to analyze that. And to show you how that works, I created a little sample project with a Spring Boot application that has a CRUD controller or endpoints for a CRUD service there. First of all, this is my domain model for this example project. It's a conference entity. We use in our service. The conference consists of the name of the conference, number of participants, and an address. And the address is another object and contains of a street, zip code, and the city. But it's included within the conference. I didn't want to make it too complicated. We use Spring Data and we use the CRUD repository they provide for us. So we don't need to create the database specific queries. And all of this is managed as a simple Spring Boot application we can run here. And the most important part, of course, is the controller. I created a controller with 4 endpoints for our 4 methods we need to create the CRUD service. The first one is a post mapping we usually use in REST to create a new element. We just get the conference at the request body and save the conference to the database, and it is returned a 201 HTTP status with a response body of the saved entity. It's important to get the path back because the ID is generated by the service itself, and we want to access the data later maybe, and so we need the ID. The second is the read endpoint. It's a get mapping. We just add an ID to the path and try to find the conference. If we can find the conference, everything is fine. We return an OK status with the conference in the response body, else we just return a 404 status. The put mapping is the most complex endpoint. It updates an element, and if it doesn't exist, it creates the element we send with the request body. And the put request contains also an ID, so we just give an ID. We try to find the old conference, and if we find the old conference, we just update it and get an HTTP status of OK with the conference in the response. If not, we do the same like in the post mapping. We just create the element and return the new URI with the saved conference in the response body. And last but not least, we also want to delete elements, and here we try to find the ID we get with the path, and if the conference exists, we just return, we delete. Of course, we have to delete the conference first, and then we send back a 204 no content HTTP status, else we return a 404. So, do you believe me that everything works? Or what could we do that to see it? Of course, we can do it. We can run an integration test. Here we can see the integration test. It just checks all 4 operations: the create element, read element, the update, and delete element. Then I added some additional checks that check if we get a 404, if we try to get a conference that doesn't exist, or if we get a 201 status, if we try to update a non-existing conference. And I also checked some client errors if we send invalid data with the request. Then we should get a 400 HTTP status back from the server so that the client knows that something with the request has been wrong. So let's just run this integration test. It's 12 tests in total, and you can see all the tests are fine. I come back to this later. Let me continue here. Speaking of the service we have seen now, we reached the REST majority level 2. And I make a promise to you now, we can delete some code in this service and we can reach a higher level, level 3, with using Spring Data REST. So what is Spring Data REST? Spring Data REST is a project of Spring Data. It's maintained and officially supported by the Spring Data people. Spring Data REST analyzes your domain model, the documents or entities you define within your project, and they build hypermedia-driven REST web services out of that. So you can get a discoverable REST API, and for example, you could navigate within your data without knowing code or domain models and so on. You can just find, for example, you can find connected entities, or if you use paging, you get provided links to the next page, to the first page, and so on. So it's really easy to work with Spring Data REST as a user, because you don't need to know too much about the project. You can just see the data you get, and that's a really nice thing to have there. They also support a lot of database or data backends. You can see on this slide, of course, there may be some missing, but for example, we started to work with MongoDB in our projects, MongoDB and Spring Data REST. And we have seen in the service I created now, I supported the get, put, post, and delete HTTP verbs. Those HTTP verbs are described in RFC 2616. And there is also the patch keyword. Whom of you already used the patch keyword? Did anyone implement the patch keyword in a service? Yes, there was no hand for implementing, 2 hands for using the patch keyword. Patch makes it easier for the client side to update data. You just need to send the data that really changed back to the server, and not the whole domain object you created. So it's simple. If you have an HTML form and you change an email address, you only need to send the changed email address back to the server. It's special for the patch keyword that the server defines how a patch has to look like. The most simple form is to just send the name of the field and the new content back to the server, but that's kind of problematic because you don't really know what should be done with this data. And there are some other patch formats, namely the JSON patch format and the XML patch format. I'll show you an example later, but it's more complex on the backend side to decode the patch and to apply the patch. But for the client, it's easier to use it, and you also need less bandwidth and can save data on the way back to the server. This is how a patch could look like. On the left side, you can see the origin object. On the right side, this is a typical JSON patch example. You can see there are 3 operations available. It's replace, add, and remove. For every operation, you have to give a path within the JSON document where you want to do some changes. And for replace and add, you can add values there. You can also add arrays or JSON objects. So it's not only strings you can replace or add. And at the end, the server applies the patch, and we hopefully get the object on the lower side back on the server. What else do we get with Spring Data REST? They provide a customized help browser. I'm not sure if you know the help browser. It's an endpoint in a service later where you can just operate on your data. You can see your data. You can do all the REST operations you are used to do to it. I'll show an example later. Spring Data REST supports paging by default. You don't have to configure anything. You don't have to write anything for that. If you query, for example, in my service, if you would query all conferences, by default it is paged, and there's a default page size and so on. Spring Data REST also supports event listeners, so you can react on events like before create, before save, after delete, and so on. And so you can intercept requests and do actions based on what happened before. And they also have validators that validate data on the request level. If you have a validator that reacts on before create or before save, you can reject data that is not valid, for example, or you can also do no, you just validate the data, and if it's not correct, you reject it. You have a detailed error object where the path is written in and so on. So it's easy to work with that after it got rejected. Let's get to another demo. I prepared a patch within my project. This patch just removes the controller, and it adds 2 dependencies, or it changes one dependency and adds another. It removes the Spring Boot Starter Web dependency and replaces it by the Spring Boot Starter Data REST dependency, and it also adds the Hell browser that is provided by Spring Data REST. So if we apply the patch, we can see the controllers are deleted and the POM XML is modified. And now we don't have any controller anymore in the project. And to see if everything still works, we just run the integration test again. And hopefully everything works. So the tests still work, and we have less code, and we have more features in there now. And I prepared another project. It's called CRUD Service Spring Data REST, where I can show you some of the special features we know from the I've mentioned in the slides right now. First of all, I added an address validator. It's just a simple address validator. It looks when the city is Berlin, the zip code has to start with a 1 and should contain exactly 5 digits. If that is not correct, we add a value to the error object. Here we add the field, and we just add some additional information, so maybe a human can read it too. Such a validator has to be registered or configured. I didn't want to write 2 validators, but I wanted to have them at 2 locations. We want to make sure that the address is validated when we create a new object and when we update an existing object. So we don't want that the address should be invalid after an update of the object. I also created event listener. Event listeners can be configured by annotations, for example. And this event listener just logs a message to my log file and says that their conference has been created. And I guess that was all what I added to this project. And of course, there's another integration test. This integration test first tests if we can update an element via patch. Here I use, in fact, the most simple way of patching something. I just send the name of the field and the value of the new value of that field back to the server, and we show if we look if we get back the new number of participants. I also create a new conference and look for a links section. There's always a links section in the document we get as response, and within this links section there is a self-reference. So I have the URL to my own in the links session, in the links section at least. And here I'm looking if I get this back. We also try to read everything from the first page. When I start up the service, I always create 50 example documents within my database, and so the first page should be filled to the default of 20 elements. And in the end, I just test if the validator works. I try to add a conference with the wrong zip code for Berlin, and I also try it when I update this conference with the wrong zip code. So let's run this integration test. So you can see every test passed the test, and now I'll show you the Hell browser itself. It runs at port 8080, and here you can see we only have one domain entity within my project. It's conferences. When I just go to the Hell browser, it shows what has been analyzed, and we can go to the conference. We can do everything by mouse here. And here we can see we get, when we go to conferences, we get back all the conferences. It's paged, default page size is 20. There are 48 elements in total in my project for now. And on the right side, we can see the response body. And at the end, we also see the links section with the reference to the first page, to the next page, last page, and of course the reference to myself. And the paging object itself is also added to such a request. Now we can see on the left side all the conferences. We could jump to one of the conferences directly. Here we again see the links section with the self-reference. And here, for example, we could just delete a conference, for example. It's the easiest thing because I don't have to create a request body. And now the conference is gone. We see a 204 no content response. And if we go to the conferences again, there should be 47 now. Yes, I deleted one of the conferences within the Hell browser. So I think this Hell browser is not made for public users, but if you just want to play around with your service, it's a great tool to analyze what comes back and how requests are made. So let's get back to the slides. We also have we detected two issues with Spring Data REST. The first issue was someone came to us and said, hey, I can delete your entities with a GET request. And we wondered, how did he do it? We had in our repository, we had a method delete by some ID as a method, and Spring Data REST exposed this method as a GET method, and so we could just delete an element via GET, and this was not good because the delete endpoint is hidden behind a secured endpoint, but the GET verbs are not hidden behind those endpoints. So you need to add an annotation that methods do not get exposed via Spring Data REST, and hopefully they will change default behavior if a repository method starts with delete, for example, that it doesn't get exposed by default. And the other issue we have, reactive frameworks are not supported right now. We hope there will be support soon, but at the moment I guess there are too few users of it, and they don't want to put the effort in it to also add reactive support. But maybe in the future, or if you all start now using Spring Data REST, we can get more drive in that direction. Okay, these are my contact details, and my talk is now over. Thank you for your attention. Are there any questions? I don't see any. Okay, so thank you.